Ands and ors. Important stuff. That's actually not all that clear in everyday English. Sorry, language is still evolving. We'll get it someday. So far, we've been talking about simple propositions, like today is Monday. Maybe it is, maybe it isn't. And it's one item that claims to be either true or false. That's called a simple proposition. There are other kinds of propositions, and we'll run through them here. Let's go with a conjunctive proposition. Two simple propositions connected by and. It is Monday, and this shirt is green. When is a conjunctive proposition true? It's only true when both parts are true. Maybe it is Monday, but this shirt is not green. So the whole thing together is false. For an and statement, blah, 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 and blah, 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 two propositions with an and between them, to be true, they need to both individual simple propositions have to be true. That's just how and works. That's what we mean by and. Or at least what formal logicians mean by and. Formal logic and everyday English have some issues. What's the other possibility? Well, there's also or. I could say it is Monday, or this shirt is green. In an or statement, or in an or compound proposition, proposition 1 or proposition 2, the whole thing is true if any of three things are true. If the first one's true, we're good. If the second one's true, we're good. If both of them are true, we're good. A disjunctive proposition, an or one, is true as long as it's not that both are false. Anything else, it's true. And this conflicts with everyday English a little bit. If someone asks you, do you want tea or coffee? I might like to say both just to poke fun at English, but generally they're not expecting you to say both. But a disjunctive proposition's true if both components are true. So if the person were speaking logically correctly, what should they have said? What should they have asked? Because really they meant Niao cha haisha cafe. Whereas in English, we don't really have a very clear difference between haisha and huoja. Wojihuan cafe huocha. Yinse gewo or huoja. Gewo cha huoja cafe. I like both of them, so give me whatever. Give me either. Maybe even give me both, but either one's okay. So we have sort of two kinds of ors. Pick one, and only one, or. And pick one, pick the other, pick both. An inclusive or an exclusive or. The term or is ambiguous. This is bad. Luckily, there's a convention. When in formal logic someone says or, they mean the inclusive or. A or B. A and B works too. In everyday English, people mean the exclusive or. A or B, but not both. Which in formal logic would be A or B and not both. Of course, A or B and not both is a little wordy, so I guess someone decided to just make that or in English. But so far, we've been trying to be very precise with language. We went into like trying to read contracts. We like precision. We don't like this ambiguity between exclusive or and inclusive or. So what does someone who really cares what they're doing do? Okay, well, in basic everyday English, exclusive or has taken and held that OR word for a really long time. We're not going to displace exclusive or's hold on that OR word. So for inclusive or, we just need a new word. Lawyers weren't all that imaginative, though, so instead of a completely new word, they really just tend to write AND/OR. And/or. And/or is the English equivalent for inclusive or. If you don't see the awkward and/or, people generally mean the exclusive or, even though they probably shouldn't. But yeah, that's or. It's a little more confusing than it should be. This is one area where Chinese probably does a better job with haisha, exclusive or huozha, inclusive or. I'm a fan of throwing down and/ors in everyday English. I think it should be a word. Not everyone agrees with my convention, though, and if you haven't noticed, I've made up a lot of conventions. There's a lot of conventions I abide by that no one else has ever heard of. If you've noticed my ampersand use, but you can read the book for my opinion on ampersands. Okay, so we've got through those conjunctions. Now, let's see. Actually, I should fix that note a little bit. No, it's good. Now, what categories of truth values can we end up with? Especially looking at compound propositions. Well, we can get some that have a truth value of 100% and some that have a truth value of 0%. By definition. And these generally aren't all that useful in solving issues. They're tautological, sort of, or self-contradictory. Or, well, no, just contradictory. Okay, so a tautology. Today is Monday, or it isn't. It's gotta be one of those, so as a disjunctive or compound proposition, that sentence has a 100% chance of being true. It is always either Monday or non-Monday. It's true, but it doesn't give us any new information. I didn't have to tell you that every day is either a Monday or a non-Monday. You could have figured that out on your own. True statement, but useless. But what if I said today is Monday and Tuesday? That sentence, that compound proposition, has a 0% chance of being true. Because it's always one day of the week at a time. It's not ever two at a time. So it can't be day 1 and day 2. Can't be Monday and Tuesday. Could be or, but not and. Today is Monday and Tuesday. Contradiction. 0% chance of being true. Again, useless. sometimes we need to filter out contradictions in tautologies, because in a real issue, in a real argument, there's enough stuff going on, it's dizzying in the best of times. So we try to eliminate the useless stuff. Get rid of tautologies, contradictions, and a lot of other things. What we really care about are contingent statements, like today is Monday. That is either true or it's false, and if we chose to make an issue of it, you could investigate it and figure out which one it is, true or false. Contingent statements are what we tend to care about. There's one more kind. If-then statements. Their formal name is Hypothetical Propositions. And these things are a little weird. However, they're pretty important. A lot of deciding on issues and hashing through logic involves a lot of ifs and thens. We have a lot of hypothetical propositions. So what is one? Okay, well, they're just if simple proposition, then other simple proposition. How do we handle the truth value of that compound proposition as a whole? Well, there are four options. There's truth and falsehood for each one of two propositions. Four possibilities. The first proposition we call the antecedent, and the second proposition we call the consequent. Just because these people like a lot of vocabulary. A hypothetical proposition is only really false if the antecedent, the first thing, is true, but the second one is false. If A, then B, and you look around, hey, nope, not B, B is false, then a hypothetical proposition is false. Otherwise, it rounds to true, although sometimes it's not really useful. Let's look at some real examples. Let's say, if the sun revolves around the earth, false, then 2 plus 2 is 5, false. They're both false. I don't know. Maybe in a crazy physics world where the sun goes around the earth, maybe it also has to be a crazy math world where 2 plus 2 equals 5. But I don't know. I don't have crazy physics world, so I can't check crazy physics world to see if it's also crazy math world. I just don't know. But I can't prove that the statement's false. Maybe one of you has crazy physics world and can check. Probably not, but theoretically possible. That's one of those not false but irrelevant ones. Now the other true but not useful. If the earth revolves around, well, if the sun revolves around the earth, false, then 2 plus 2 is 4. Well, yeah, 2 plus 2 is 4. The consequent is true. But is it because? Is the connection, is the syllogism valid? Well, I look outside, nope, the sun does not revolve around the earth. I would need to look into crazy physics world to check that. Maybe in crazy physics world math stays the same. I don't know. I can't know. But since I can't know, I can't really prove that hypothetical proposition to be false. It's in category. So those are the two possibilities where a hypothetical proposition could be trivially true. Here's the one where it's definitely false. If the Earth revolves around the sun, true, then 2 plus 2 is 5. False. And we can and we know that the syllogism is bad. Because we can verify the antecedent, we can look outside, yes, we have Earth goes around the sun world, we can check this. And then we also check math. Nope. That connection must be invalid. The other possibility is that they're both true. If the Earth revolves around the sun, then 2 plus 2 is 4. True and true. This one's... it's not, like, unverifiable, but it's hard to check the syllogism. Does 2 plus 2 equals 4 because the Earth revolves around the sun? Or is it just a coincidence? They happen in for different reasons, and it's just two things, and I just put a then before one and an if before the first one. Is there a real connection? Deciding on that is the job of science. It's hard. We will do that in Chapter 13. So with hypothetical propositions, we have two possibilities where it's not technically false, but it's useless. One where, yeah, both parts are true, and we'll decide if there's any causal relationship. The only time where a hypothetical proposition is logically definitely false is when the first part's true, but the second part's false. That you can nail down by logic alone. Playing around with these things can be difficult, but they're the building blocks of arguments. How to put them together we'll get to next time, but it's good to at least know what the blocks look like. And propositions can get big. You can have complex propositions, where it's got a bunch of ands, a bunch of ors, maybe an if-then in there, and it goes on and on and on. Like, Genghis Khan was Mongolian, but if Julius Caesar was Roman, then Napoleon was German and Alexander the Great was famous. You can have giant propositions that are just hard to deal with. Usually we try to avoid those monster ones, but if we really have to, we can get out a piece of paper and start diagramming it with arrows and formal logic, if we really have to. Usually we don't have to go that far, but it's nice to know that the power tools are there in the toolbox. Okay, so you've had a tour of the possibilities of propositions. Next time we'll get into putting them together into arguments, which are the things that we use to answer questions and decide on issues. The real useful stuff that we're actually trying to accomplish as our end goal. Well, thanks for staying with me. Yep, talk to you later.